Welcome Wildcats, welcome back from break. We are now looking at the next area that we need to be talking about. Now I told you guys going into break that we were actually going to hop right into picking up where we left off because we left off at 4.6. So let's take a look at 4.7, which is complex solutions of polynomial equations. So we spoke before about rational solutions, and we are still going to use a lot of that information, but now we're going to take it one step further and talk about complex solutions in addition. So many of you guys will probably not remember what a complex number is because we haven't talked about it yet, and a lot of you guys will not be real comfortable with it, and that's absolutely fine. We will get from step one to step whatever. The nice thing about these though is you're going to be able to use a lot of the steps that you used when you were doing the rational roots. So I'm going to recommend that you graph it first. Desmos is the obvious way, but if you've got access to a TI Inspire or a TI-84, you can graph it with that as well. Once you've graphed it, remember, wherever that graph crosses the x-axis, that is a rational root. You're then going to take your rational roots and use synthetic division to pull out all of the rational factors. What you're going to be left with is a quadratic. So something squared plus or minus something plus or minus a constant. Then you guys briefly in Algebra 1 talked about the quadratic formula. We're going to talk about it quite a bit now. You're going to use the quadratic formula to find the two complex roots that the equation has. So as always, let's take a look at an example. So, let's say we needed to find the roots, all of the roots, of 3x cubed minus 25x squared plus 30x minus 14. If you were to graph this on Desmos, you would see that it crosses at x equals 6. So that means x minus 7 is a factor. If that is a factor, then we're going to need to divide it. You can use long division with x minus 7, or you can set it up with synthetic division, taking your coefficients, 3, negative 25, 30, and negative 14, along with the opposite of the negative 7, so you'll take 7, and then we'll just run through the process of synthetic division. So you'll drop down your 3. 3 times 7 is 21. Negative 25 plus 21 is negative 4. Multiplying that again by 7, you get negative 28. 30 minus 28 is 2. 7 times 2 is 14. And negative 14 plus 14 is 0. Do remember that when you have a 0 at the end, that's a good thing because that means that what you have divided is a factor. Now keep in mind, we already knew that. We already knew because we graphed it that x minus 7 was a factor of 3x cubed minus 25x squared plus 30x minus 14. The reason we had to use this synthetic division though was to get the quadratic that we're going to use. So now that we know that if we divide our original problem by x minus 7, we're going to get 3, negative 4, 2 gives us 3x squared minus 4x plus 2. So the rational 0 for this equation, the one time it crossed the x-axis, is 7. We need to use the quadratic formula to find our two complex roots. I'm actually going to do this on the document camera so that you guys can follow along with me a little bit easier. So the equation that we have is 3x squared minus 4x plus 2. Now, as I mentioned, you guys have seen the quadratic formula before, but you may not remember it. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that's a bunch of letters without a lot of context. So let's give it some context. Remember that ax squared plus bx plus c is our standard form. So if this is standard form, and this is our quadratic formula, and this is the equation we're talking about, then we know that a is going to be the coefficient of x squared. So a is 3. B is going to be the coefficient of x. So in this case, make sure you keep the sign with it. B is negative 4. And then c will always just be your constant term. So 2. So now what we have to do is take this equation, and everywhere you see an a, plug in 3. Everywhere you see a b, plug in negative 4. And everywhere you see a c, plug in 2. So the equation starts off with a negative, and then I need a b, negative 4. Plus or minus square root b, negative 4. Notice that I'm putting these in parentheses. Squared minus 4 times a, which is 3, times c, which is 2, divided by 2a. 2 and a is 3. Negative negative 4 is just 4 plus or minus the square root. Negative 4 squared, so negative 4 times negative 4, that's 16. 4 times 3 is 12, times 2 is 24. 2 times 3 is 6. So 4 plus or minus square root 16 minus 28 is negative 8 over 6. Now, here's where a lot of people start having a problem. When we first started talking about square roots, you guys learned that you can't take the square root of the negative number. And that's technically true. However, a complex number is a number where you do take the square root of a negative number. And we use the letter I to represent that. We've talked about this a little bit, but not a lot. So, if we have the square root of negative 8, then that's going to be 4 plus or minus the square root of negative 1 times the square root of 4 times the square root of 2. Now the reason I broke it up this way was because then you can see that the square root of 4 is 2. Another way that people commonly write this is they'll actually take the prime factorization of 8. So they'll actually notice that that is 2 times 2 times 2, and they'll pair them up. Either way works, because either way you can either pull out a pair of 2's to get a 2 on the outside, or you can take the square root of 4 to get a 2 on the outside. But either way, you end up with 4 plus or minus the square root of negative 1 is I, the square root of 4 is 2, and the square root of 2 is simply the square root of 2. 4, 2, and 6 are all even, so this 4 can become 2, that can become 1, and this can become 3, giving us a final answer of, this is going to be very smallly written, 2 plus or minus I root 2 over 3. So 2 plus or minus I times the square root of 2 divided by 3. This does not simplify. This is as simple as it gets, so that is actually our complex root. That's the answer that we're looking for. So, going back to the slideshow real quick. I did go through all this math on the slideshow. It's a little messy though because the square root sign doesn't show up very well. But I'm going to go ahead and let you pause it here for a moment if you would prefer to try to take notes off of that instead of taking the notes off of the board that I wrote it on. So, long story short, we now know all three roots. The three roots, or the three zeros, are 7, that's the one that we found by graphing, and then by using synthetic division to get the quadratic, we were then able to use the quadratic formula to get 2 plus I times the square root of 2 over 3, and 2 minus I times the square root of 2 over 3. Now guys, this problem was taken directly out of your textbook, so you are able to go in and see that. This was one of the versions of problem 2 or 3 for your current homework assignment. However, that is everything you need to know for this section. Again, this is 4.7, complex roots. What that means, guys, is you now have an HRW assignment and you have today and tomorrow to work on just that. We will be continuing with other stuff for the rest of the week, Thursday and Friday afterwards. So guys, good luck.